Hey everybody, wanted to run through what I did to this Clayton Smog dyno to change it into a performance-based chassis dyno. These guys are really common out here on the West Coast. I picked this one up for $400. It is in all original mechanical shape. I just had to change the electronics out. I got it off of a shop that didn't want to do hot smog anymore. They didn't see a reason to repair this. The VFD had failed. If you're looking to buy one of these, I would definitely say try and buy one with a VFD that works. That'd be great. Usually that's not what causes these to be sold. Typically the shops just don't want to do smog anymore. Quick run through of what this Clayton dyno has. So 4 rollers, they're 8.572 inches, which is very common. In between the rear rollers, you have a 3 horsepower, 3-phase motor. And then over here on the end, you have a non-vented flywheel eddy brake that is belt driven through a 14M pitch belt that is about 50 millimeters wide. It's very common in industrial applications. You can, if it ever breaks, you can buy another one. I've considered getting a different pulley so that this is driven 1-to-1. Right now there is a 34 tooth pulley on top and the lower pulleys are 48. If you want to go faster, you can change the pulley size out to make sure you don't overspeed the flywheel. In addition, over here you've got the original encoder down there. The pinout is on top. It's 500 pulses per revolution, which is a lot. I haven't changed it out because this is only limited to 85 miles an hour, but if I re-gear it, I will likely change out to a lower tooth count encoder of some kind. Then looking at the eddy brake, so it's a 4-coil eddy brake. These are capable of doing 100 volts at like 30 amps. You don't want to go much over that, and my power supply is only rated for 30 amps. As well, since this is non-vented, you need to really be careful about temperatures. I've got a thermocouple that's taped onto this coil, so I have some idea of what the coil temperatures are. Haven't gotten it very hot yet, but you can definitely burn the enamel off of the magnet wires. Eddy brake itself is floating on a bearing, so this shaft passes all the way through. Most of the bearings on here, so you can see a grease fitting there. Most of the bearings are greasable. Definitely, if you go to buy one of these, spin everything over, make sure that the system rotates freely, you don't hear any weird noises. Each of these dynos comes with a spec plate. They're in multiple locations. There should be one on the front here. So 150 horsepower is pretty common. Some of the ones that are geared 1-to-1 can do 250 horsepower. Max speed, like I said, 85. You can re-gear it 1-to-1 if you want to go a little faster than that. Roller diameter, yeah, 8.572 inches, fairly common. And then as far as this base inertia goes, I've determined the moment of inertia of this, and it's not 2,000 pounds. I don't know what they're referencing with this number, but yeah, it's still, though, that 2,000 pounds of inertia is pretty common spec to see. If you're gonna run one of these though, be sure to determine the inertia on your own because you cannot plug that value in and get accurate numbers. And then as far as sensors go, the only other sensor that really matters on this is this load cell down here. Original load cell as well. I just figured out the pinout and plugged it into the Dyno Controller. And then with regards to the Dyno Controller, this is the weather station that comes with it, so that monitors temperature and humidity. I put that there temporarily, but I'm going to move it. Definitely as I use the eddy brake and it starts to warm up, you can see a steady rise in what's considered to be the ambient temperature. I didn't know where this guy was going to end up, and I didn't want the weather station to get damaged, so I tucked it inside, but I'm going to have to pull it out and put it somewhere else. This thing's not moving now because it is bolted to the floor. And then as well, there's an airbag lift system that I recommend you wire in if you got one of these. If it doesn't work, that's not a big deal. Some of these have busted bags, but if it does work, it's really nice because you can use this to lift up the car and break the drums, so you can just drive right off of it. It runs on 120 volts, so I've just wired it straight up to 120 volts right here. There's no power going to the system. The bags are located underneath this bar here. There's 4, I believe. There's also some ways to measure the weight of the rear axle. I have just looped up and tucked all those wires. I don't think I'll ever use them. Coming over here to look at the electronics. Like I said, I gutted everything from this box. There were some really large boards here, and then some even mounted on the door. Starting with power input, I've got 240 single phase coming in right here. Then it goes through this junction block. When you go to buy one of these, if you can, I highly recommend checking the continuity between these two. So that is 9 and 10. This is your eddy brake. You'll want to, or sorry, so 8 and 9. Sorry, 8 and 9. Check the continuity between 8 and 9. This is your eddy brake here. It's labeled PAU. And then these are your motor phases right here. You'll need to disconnect whatever modules are on this side so you know you're getting a good reading and not having continuity on the other side. But yeah, if you don't have a burned up coil in the eddy brake and you don't have a burned up coil in the electric motor, everything else is really easy. Those are kind of your big items. And even if you do have a dead eddy brake coil, you can usually get stuff like that rewound at different companies. So if you're really motivated, don't let it turn you away if you're getting a sweet deal. But those are the things that would have stopped me from wanting to purchase this. Everything on this side of the junction block, I have pretty much rewired. So coming over here to the VFD Dyno Pulls GS20, it's about 3 horsepower, which is what that electric motor is rated for. I would recommend buying a higher power VFD than this, just because I've had some issues trying to calibrate it where I would hit the current limit. It's not a showstopper, it's just you've got to be a little more careful when you're trying to calibrate the dyno. Then main reason for bringing power in when I'm running the dyno is this power supply here. Bought this from your dyno along with the controller. The power supply is $550 and it does 0 to 200 volts DC at 30 amps, which is incredible that you can get a power supply for that cheap and that it's programmable. Right here you can actually see this is the Bluetooth antenna, so those communicate via Bluetooth, so you can monitor the outputs of the your dyno power supply. And those are the only 2 things that are using power. The brains of the operation now is this your dyno box here. So it is taking in the load cell, so it can take in 2 load cells here for 2 independent brakes. K-type thermocouple. There's a couple more analog inputs here. Then you've got 2 encoder inputs, 2 power supply outputs, and then this is the weather station that comes with the your dyno box. So it measures ambient temperature, pressure, and humidity. Then there's a CAN bus on this chip as well, which is really nice. So I plan to hook this to some of the cars that I am running, and you can log, along with all of your engine tuning parameters, the output of the dyno. So the torque and the horsepower and the brake percentage and all of that via CAN bus, which is a really big deal if you're trying to precisely calibrate a car and not just go for some big number. Other things that I've done here to help with the calibration of the dyno itself are adding strips. So here's one on the flywheel. This is so I can measure the speed of the flywheel, and then this one is so I can measure the speed of the rollers. Like I said, it's not 1-to-1, so those are rotating at different speeds. You can either calibrate this in the rotational reference frame of the rollers, which is what I did, or you can calibrate it in the rotational reference frame of the flywheel, which is what your dyno recommends, but your wheel torque and wheel horsepower numbers could possibly be off a little bit because of the ratios. I use this digital tachometer to measure the speed and verify that the encoder was working correctly and that I was getting good data. that's been an extremely valuable tool in trying to calibrate this guy. Plug this guy in real quick. I had to rewire my shop from being 20 amps to being able to handle 30 so that the VFD would stop tripping the breaker. I never had any issues with the eddy brake tripping the breaker, but the VFD definitely did a few times. So here we are, everything's powered up. VFD, really simple to use once you get it set up. The documentation on this guy is just great. I'll probably buy another one whenever I need one later on. But we'll say dial it up at 3 hertz, run it. After you get this calibrated and are able to get what you think are accurate numbers for the moment of inertia and the bearing drag, you really don't need the VFD anymore unless you start to have problems. I don't think that I will need to recalibrate this for a while, so it's kind of just going to sit here. That's why I didn't invest a lot of money in a big one, but it may even get pulled out and repurposed for a mill or a lathe at some point. The dyno is bolted to the floor, but I have not had a chance to add studs or anything into the rest of the floor so I can strap cars down. Right now, what I do is I run one strap through the front tire and loop it through, and come back and tension it that way. So all of the forward force is handled by those. And then back here, I have a strap that I run up and around the bumper support on some of these cars. So here, and that is what tensions the tires into the rollers a little bit more, make sure I don't have traction issues, and also stabilizes the rear. So notice how the front straps go almost only forward, whereas these are a bit more horizontal, so right left, so that stabilizes the car from right to left. You can see both sets there holding it. So I already made a session for this Clayton Dyno walkthrough. So we're going to load that session, select that folder. So there's a lot of different ways you can set up this layout. I prefer the time-based plots for power and torque, and engine RPM as well. Whenever you go to load the dyno or load your car on your dyno, you're going to need to set up things like gear ratio. So that gear ratio is left over from another run or another build. So I'll have to set that, show you guys how to set it. Then you have all these different sweep options. So that's under brake setup, and you can go through. So you've got your control loop, which is valid for everything. You got manual brake control, so that's like your steady state stuff. Change how much you increment. You got RPM curve, so you can dial in a specific curve and it'll try and hit it. By the way, this can go up and down. Power sweep, which is what most people are accustomed to. So starting at 2500 RPM for this, we're gonna shut it down at 6,000. 500 RPM per second's fine. When setting up the gear ratio, there's a couple options. You can enter it manually, or you can use the tachometer. So what you want to do is set whatever RPM you're going to target with the engine, and then whenever you get there with the engine, you just click lock gear ratio and it'll automatically calculate it. Once you get your gear ratio set up, you're going to do your moment of inertia setup. What it wants is me to accelerate to 100 kilometers an hour, and then it'll take a measurement, and that's a coast down with no braking. And then I will accelerate to 100 kilometers an hour, and then it will apply the eddy brake at whatever percentage I have set up here. So here it is 25%. You can estimate an engine moment of inertia. I leave that at 0 because I really don't like adding any estimations or modifiers to this. At the end of the day, you can, with a dyno, make whatever number you want to show up by playing with these figures. What really matters though is how much power is actually going to the wheels, how much torque is actually going to the wheels. So if you can calculate an accurate moment of inertia, that's pretty good, just to get a better understanding of like engine power. And that's what some of that's used for, and the coast down test as well. Also, this test, the moment of inertia wizard, is how I determined the moment of inertia of the dyno itself. I just set the roller hub moment of inertia to 0, and then use this to measure the moment of inertia, and then it will calculate whatever the rotational moment of inertia is, which if you don't have anything on the dyno, is just the moment of inertia of the dyno itself. Of engine RPM, and then you can also see the eddy brake temp over here is kind of up a little bit. So yeah, the difference in slopes here along with the force that was detected at the eddy brake itself is what helps them calculate the moment of inertia. So I'm just going to save and close with this, and then I am ready to do a power sweep. 2 pulls, and then look at the data. See, we got a little more torque here. Some of that's possibly due to torque converter slip, but all in all, repeatability is quite high. We're within 1 Newton meter of the same peak torque and within like 2 horsepower at around 6,000 RPM. If you look up 1987 BMW 325i, The horsepower and torque numbers are very close to that. Here you can see the measured power and torque, which are quite a bit lower. When I go to calibrate and actually look at cars, I usually just care about torque. Torque is all you're looking for when you're adjusting timing, adjusting fuel. Where is MBT? Now, as far as checking like car health and engine health, things like being able to see, okay, my max engine power is close to what people advertise is the power level that this car should have, which is 160 horsepower, and torque's pretty close as well, and the curves are the right shape. If anyone has any specific questions or wants me to do another run through, I can do a lot more. Definitely plan to post more videos of me tuning cars with this once I get that kind of side business up and going and I'm able to calibrate more. Thanks. Please like, subscribe, leave any comments if you have any specific questions. Love to help people out and grow the community here. It's beneficial for all of us to discuss this stuff. Also, if you see any oversights or mistakes that I made, feel free to point them out in the comments section. This video is about the dyno, but I did want to add a little teaser of the next project that's going to be getting posted on here. This is a 2000 Ford Ranger with a 2JZ GTE VVTi, a T56 transmission from Granis Racing. It's the GR700, and then an 8.8 in the rear that's mostly stock with some different clutches in it. I've done a lot of work to this over the past few years. The goal is to compete with it at the Optima Ultimate Street Car Shootout in the truck class. I'll be posting a ton more videos on it recently. I've got a huge backlog of videos that I needed to post and just haven't been able to. So it's going to be coming to life here in the next few months. I wanted to get it closer to done before I started posting videos of it. But yeah, there's a whole lot here. It's going to be getting calibrated on that dyno as soon as it runs. And I know it's going to need a lot of effort because no one's really done a setup like this. So having that dyno is going to be really helpful. I've got a lot done, even in the interior. I've already converted the dash over to a Motec display, a couple other things. I've got a Link ECU that I just picked up from Drift Motion yesterday that I'll be throwing in this. But wanted to have a little teaser on here. So